mission was almost over. 9 days of floating, freeze-dried food, wet wipe showers, and staring at a moon no human had seen up close in over 50 years. Reed Wiseman, Victor Glover, Christina Koch, and Jeremy Hansen had done everything. They had manually flown Orion around the far side of the moon. They had broken the all-time distance record for human spaceflight. They had named craters. They had laughed and floated and looked out their windows at an Earth so small you could blot it out with your thumb. Now all they had to do was come home. And that is where the story gets complicated. Because coming home meant betting their lives on a piece of hardware that had already failed once. Not metaphorically. Not in a stress test. In actual flight. And nobody could say for certain it would hold this time. Let's back up. When Artemis I flew in November 2022, it carried no crew. The mission was a test run, a full loop around the moon and back, everything but humans. The capsule came home, splashed down in the Pacific, looked fine from the outside. And then the engineers pried it open and started inspecting the heat shield. What they found shook the program. More than 100 locations on the shield had cracked, fractured, and broken off in jagged chunks. Not the smooth, controlled burn-away the design called for. Pieces of the protective material had simply blown off the spacecraft like chunks of drywall off a wall that got hit too hard. Some of the 4 bolts embedded in the shield had partially melted through their own thermal barriers, leaving deep gouges. Nobody expected any of it. The culprit turned out to be something called permeability, or rather the lack of it. During re-entry, the outer char layer of the avcoat shield hardens and becomes less permeable. But the material underneath is still incredibly hot, undergoing a process called pyrolysis, which is basically combustion without oxygen. That process generates gas. And if the gas has nowhere to go, pressure builds, and the material cracks and blows apart from the inside. The skip re-entry maneuver Artemis I used made this worse. The capsule dipped into the atmosphere, bounced back up, and then came down again. During that second climb, the outer char layer had paused its ablation, but the interior was still scorching hot and still generating gas pressure that had nowhere to escape. The cracking wasn't survivable by luck. It just happened not to go all the way through. If any of those fracture points had burned deeper, the aluminum walls of the capsule would have been exposed to plasma. Engineers noted that any one of those locations could have allowed the heat of re-entry to burn through the spacecraft walls, the same way the shuttle Columbia broke apart in 2003. And there was no escape system. If the heat shield fails during re-entry, you cannot eject. You cannot punch out. You cannot radio Houston and ask for a plan B. There is no plan B. It either holds or it doesn't. So now NASA had a problem. Artemis II already had its heat shield installed, nearly identical to the one that had just cracked and failed on Artemis I. Rebuilding from scratch would have pushed the mission back by 2 years or more, and nobody wanted that. So they did something unusual. They kept the same shield and changed the path instead. The new re-entry trajectory eliminated the skip entirely. Instead of dipping into the atmosphere and climbing back out, Orion would descend in one continuous straight shot. More sustained heating throughout, which engineers said was exactly what was needed to keep the avcoat permeable enough to let the gas escape normally. No pressure buildup. No cracking. The trade-off was higher G-forces on the crew during descent. A steeper path means a harder, faster slowdown. But the engineers believed the shield would hold. Most of them anyway. Not everyone agreed. Dr. Charlie Camarda, a heat shield expert and former NASA astronaut, publicly called the decision to fly crew on the modified but still damaged design shield irresponsible. He argued that NASA had not fully understood all the failure mechanisms and could not accurately predict how the shield would behave on this new trajectory. He said he walked away from a January 2026 briefing at NASA headquarters unconvinced. He was not alone. There were engineers on the outside of the program who felt the agency was moving too fast, too confident, with too much riding on analysis that hadn't been validated in actual flight. Victor Glover knew all of this. He later said he had been thinking about re-entry since April 2023, the day his crew was announced. One of the first press conferences, we were asked, "What are we looking forward to?" he said. And I said, "Splashdown." It's kind of humorous, but it's literal as well. "We have to get back." He had seen the photos of the cracked Artemis I shield. He had sat in the briefings. He had met the engineers. He had made his decision. They all had. Now it was April 10th, 2026. Flight day 10. At around 5 in the afternoon Pacific time, the crew wriggled back into their orange pressure suits, the same bulky, wearable lifeboats they had worn at launch. For the past 9 days, those suits had been stowed. Now they were a necessity again. The service module, the cylinder bolted to the back of Orion that had provided their power, propulsion, and oxygen for the entire journey, was jettisoned. It floated away and would burn up in the atmosphere on its own. At 7:53 p.m. Eastern, with Orion about 76 miles above the Earth's surface, the crew oriented the capsule rump forward. The heat shield pointed down. The descent had begun. The spacecraft hit the discernible upper atmosphere, traveling 24,000 miles per hour, fast enough to fly from New York to London in under 10 minutes. Within seconds, temperatures across the 16.5-foot wide heat shield climbed toward 5,000 degrees Fahrenheit, roughly half the temperature of the visible surface of the sun, as the capsule rapidly decelerated in a fireball of atmospheric friction. Inside, the astronauts felt the forces build. First a gentle tug, then a steady push, then a weight pressing them into their seats that just kept growing. Breathing required effort. Every breath was a small fight. The windows, small as they were, began to glow. Orange at first, then white, then a light that didn't look like anything they had seen before. Glover later said he could tell they were in a fireball. His first thought, looking at the plasma wrapped around the capsule, was, "Is it supposed to be that big?" Which is one of those sentences that sounds like a joke until you realize it came from a man sitting inches away from material burning at half the temperature of the sun, wondering if the heat was within spec. At 7:53 p.m., Houston lost contact. The plasma surrounding the capsule was so electrically charged that radio signals couldn't pass through it. The communications blackout was expected to last about 6 minutes. 6 minutes where mission control had no telemetry, no voice, no data, just silence and a dot of fire crossing the Pacific sky. For the crew, it was the same silence in reverse. No voice from Houston, no confirmation. Just heat, pressure, and the sound of the spacecraft burning through the atmosphere at a speed that should be lethal. The aft-coat on the heat shield was doing its job, absorbing the fire and slowly burning away, carrying the thermal energy with it, layer by layer, a few inches of material standing between 4 human beings and vaporization. Wiseman later said that he and Glover, watching through the capsule's cameras, maybe saw 2 moments of a touch of char loss during the hottest part of re-entry. And that was it. The shield was holding. When the capsule slowed below supersonic speeds, the drogue parachutes fired and yanked the vehicle into a stable descent attitude. Then the 3 main chutes billowed open above the Pacific. Glover said that the moment the parachutes released just before splashdown, he felt like he was in free fall, like diving backward off a skyscraper. That's what it felt like for 5 seconds, he said. And then the ride smoothed out. It was glorious. Orion hit the water at 17 miles per hour, under the control of 3 116-foot diameter parachutes, splashing down in the Pacific Ocean off the coast of San Diego at 8:07 p.m. Eastern on April 10, 2026. The USS John P. Murtha was already in position. Navy divers hit the water, attached flotation collars and the winch line. The hatch opened. Christina Koch was the first one out. She later described the moment the hatch swung open. "I was completely overcome," she said. "I just screamed. I was so happy. It was just pure elation and just a visceral, emotional reaction to not only being home, but people they're coming to us and bringing us out. Just unspeakable joy." Wiseman made his way to the USS Murtha and asked to see the ship's chaplain. He had never met the man before in his life. "When that man walked in, I saw the cross on his collar," Wiseman said, "and I just broke down in tears." Navy divers photographed the heat shield immediately after splashdown. Initial inspection showed that the char loss behavior seen on Artemis I was significantly reduced, both in quantity and in size. The performance was consistent with what the arc jet tests on the ground had predicted after Artemis I. The shield was going to Marshall Space Flight Center next for X-ray scans and sample extraction, to understand down to the material level what happened during those 6 blackout minutes. But for now, looking at it from the outside, the engineers were smiling. Wiseman told reporters, "For 4 humans just looking at the heat shield, it looked wonderful to us. It looked great, and that ride-in was really amazing." He immediately added that they would fine-tooth comb every atom on the thing before drawing conclusions. But the smile didn't leave. NASA Associate Administrator Amit Kshatriya spoke to the press shortly after splashdown. "I think the path to the surface is open now," he said. "This was an incredible test of an incredible machine. I think this has been a gift to the world. Here is what all of this means when you strip away the engineering language. 4 people agreed to sit on top of the most powerful rocket NASA has ever launched, travel farther from Earth than any humans in 54 years, and then come screaming back through the atmosphere at 24,000 miles per hour, protected by a heat shield that had cracked during its only previous test. Not a simulation, not a computer model. Actual cracks in actual material on an actual spacecraft that had flown an actual mission. And they got in anyway. They got in because they had read the data, because they had met the engineers, because they believed, after all of it, that the math was right and the fix would hold. And because even if it wasn't perfectly right, someone had to go first. Someone always has to go first." The shield held. The parachutes opened. The ocean caught them. It was the first crewed mission to the moon in 54 years. 694,481 miles total. Start to finish. Fire to water. And the only thing separating those 4 people from the vacuum on the way up, the void on the way out, and the plasma on the way home was math, materials, and the decision to trust the people who ran the numbers. That's exploration. It always has been.